the United States has made a return to the moon, while China's lunar probe has successfully come back to Earth. China is expected to launch around 100 space missions this year, setting a new record for the country. Over the years, China has become a strong competitor in the space race, proving its advanced technology with a massive new space station. While this is seen as an incredible achievement in aerospace engineering, not everyone shares the same view. Elon Musk, the mind behind SpaceX, visited this space station and came back with a concerning message. He stated, "I just saw China's new giant space station, and it's not good." What did he see that caused him such concern? Let's take a closer look at China's growing space ambitions. China's journey into space started in a modest way. On April 24, 1970, China launched its first satellite, Dongfang Hong-1, into orbit. This achievement placed China among the top spacefaring nations, making it only the fifth country to send a satellite into space. The satellite continuously played a patriotic song, announcing China's arrival in space exploration. However, progress was slow in the beginning. While the United States and the Soviet Union dominated the space race, China remained in the background. It wasn't until the 1990s that China began making serious advancements in space technology. To accelerate progress, China created the China National Space Administration, CNSA, in 1993, along with the China Aerospace Science and Technology Corporation, CASC, to oversee space development. These organizations were responsible for launching ambitious space programs and improving rocket technology. The Long March rocket series became the foundation of China's space missions. Even though China had limited cooperation with Western space agencies due to political tensions, it remained determined to achieve self-reliance. By the early 2000s, China had reached an important milestone. In 2003, it successfully sent its first astronaut, Yang Liwei, into space aboard the Shenzhou 5 mission. With this achievement, China joined an elite group of countries capable of human spaceflight. Over the next 2 decades, China continued to push boundaries. In 2013, it became the third country to successfully land on the moon with the Chang'e 3 mission, deploying the U-2 rover to explore the lunar surface. 6 years later, in 2019, China made history by landing the Chang'e 4 mission on the far side of the moon, something no other country had done before. China was not just focused on the moon, it also had its sights set on Mars. In 2020, China launched its first interplanetary mission, Tianwen-1, sending an orbiter, lander, and rover to Mars. By May 2021, the Yurong rover successfully landed on the Martian surface, making China the second nation, after the United States, to operate a rover on Mars. This achievement proved that China was not just catching up, it was leading in key areas of space exploration. China's long-term space ambitions go far beyond the Moon and Mars. One of its main goals is to establish a research station near the Moon's south pole by the 2030s. In collaboration with Russia, this station will support long-term human presence on the Moon for scientific studies and resource extraction. At the same time, China is planning a manned mission to Mars as early as 2033, with plans to build a sustainable human outpost. The ultimate goal is colonization, similar to Elon Musk's vision with SpaceX. China has also announced plans for deep space missions, including an exploration of Jupiter in the early 2030s. These missions aim to study habitable planets, black holes, and even extraterrestrial life, proving China's commitment to space discovery on a global scale. With these plans in motion, China has positioned itself as a major force in the future of space exploration. The unveiling of its massive space station is a crucial part of this vision. However, Elon Musk's recent visit to China's space station left him deeply unsettled. Musk, who has dedicated his career to making humanity a spacefaring civilization, saw something in China's station that worried him. To understand this, we need to explore Musk's journey in space exploration and what he discovered inside China's new station. Elon Musk's story with space began in 2002 when he founded SpaceX. However, the idea took root in his mind much earlier. By the late 1990s, Musk had already made a fortune by co-founding companies like Zip2 and PayPal. But instead of retiring in luxury, he turned his attention to space exploration. He was frustrated with how slowly humanity was advancing in space travel. The biggest obstacle was the cost of launching rockets, so Musk sought to make space travel more affordable through innovative rocket technology. Initially, Musk wanted to reignite public interest in space by launching a small greenhouse to Mars, a project called Mars Oasis. His goal was to grow plants on the Martian surface to prove that life could survive there. To make this happen, he needed a rocket. He traveled to Russia in hopes of buying a refurbished missile but was met with high prices and dismissive attitudes. That's when Musk had a realization: rather than buying a rocket, he could build one himself. In 2002, he established SpaceX in California, investing $100 million of his own money. SpaceX's first project was the Falcon 1 rocket, designed to send payloads into orbit at a lower cost than traditional rockets. Unlike NASA's expensive one-time-use rockets, Falcon 1 was built with reusability in mind. However, success didn't come easily. Between 2006 and 2008, SpaceX attempted 3 Falcon 1 launches, all of which failed. The first crashed into the ocean due to a fuel leak, the second suffered a malfunction, and the third experienced engine failure. These failures nearly bankrupted Musk, as he had invested almost all his money into SpaceX. He had just one last chance. On September 28, 2008, SpaceX successfully launched Falcon 1 into orbit, becoming the first private company to achieve such a feat. This breakthrough saved the company and proved to investors that SpaceX was capable of delivering on its promises. Soon after, NASA awarded SpaceX a $1.6 billion contract to send cargo to the International Space Station, ISS. This contract gave SpaceX the funding and credibility it needed to move forward. With NASA's support, SpaceX developed the Falcon 9 rocket, a more powerful, partially reusable launch vehicle. The first successful Falcon 9 launch in 2010 led to even bigger achievements. In 2012, the Dragon spacecraft became the first private spacecraft to dock with the ISS. In 2020, SpaceX successfully sent astronauts into space with the Crew Dragon spacecraft, marking the first time a private company had done so. SpaceX also developed the Falcon Heavy, the most powerful operational rocket in the world, and launched Musk's personal Tesla Roadster into space in 2018. However, Musk's ultimate goal is to make humans a multiplanetary species. This led to the development of Starship, a fully reusable spacecraft designed for deep space missions. Starship can carry up to 100 passengers and is intended for travel to Mars. Although the early test flights ended in explosions, each failure provided valuable data. By April 2023, SpaceX successfully launched Starship with its booster, bringing Musk's dream of Mars colonization one step closer to reality. NASA has even selected Starship as the lunar lander for its Artemis program, meaning it will be used to transport astronauts to the moon. Despite these advancements, Musk's visit to China's new space station left him with serious concerns. What exactly did he see that made him uneasy? For now, the unveiling of China's Tiangong space station has showcased decades of careful planning and innovation. Unlike the ISS, which was built through international partnerships, Tiangong was developed entirely by China. The space station's construction followed an accelerated timeline, achieving full operation in just 18 months. Its modular design allows for future expansion, making it a key part of China's long-term space strategy. China's space station represents the country's ambition to establish a permanent presence in space. The next step remains unclear, but Musk's concerns suggest that China's advancements may have deeper implications for the future of space exploration. The Tiangong cargo spacecraft played a vital role in delivering essential supplies to the space station, docking automatically without any human intervention. China had already demonstrated this technology successfully with Tiangong 1 and Tiangong 2, refining the system before applying it to the full-scale space station. The design of Tiangong balances size and efficiency. While smaller than the International Space Station, ISS, it was built to make the best use of available resources. Its advanced solar power system features flexible solar panels that generate more energy per unit of surface area compared to traditional rigid panels. This innovation allows Tiangong to maintain high energy efficiency while staying compact. A major engineering achievement in the station's construction was the development of an Advanced Environmental Control and Life Support System (ECLSS). These systems efficiently recycle air, water, and waste, reducing the need for frequent supply missions from Earth. This capability is crucial for China's long-term space ambitions, especially as the country aims to establish a lunar research station in the coming decades. International collaboration played a limited but important role in Tiangong's development. In the 1990s, China exchanged technology with Russia, particularly in space docking and extravehicular activity suit designs. Although China later pursued its own independent approach, early cooperation with Russian space engineers provided valuable knowledge that contributed to the space station's success. Despite being excluded from the ISS due to US restrictions under the Wolf Amendment, China has invited foreign astronauts and scientists to conduct research on Tiangong, positioning it as an alternative platform for space exploration. Tiangong is a symbol of China's self-reliance in space exploration. Unlike the ISS, which was built through collaboration between NASA, Roscosmos, and other agencies, Tiangong is entirely operated by China. This independence highlights China's advancements in space technology and its strategy of reducing reliance on Western space agencies. With the completion of Tiangong, China has joined the ranks of nations capable of maintaining a continuous human presence in orbit. The station is expected to operate for at least 15 years, serving as a hub for experiments in microgravity research, space medicine, and materials science. While its construction is complete, the station will continue to evolve with potential expansions and future scientific missions. Tiangong's development represents a major milestone in space exploration. It is both a technological achievement and a strategic statement, asserting China's capability to operate independently in space at a time when global competition is increasing. However, not everyone sees this development positively. Some, including Elon Musk, view Tiangong with concern rather than admiration. Now that the station is fully operational, it serves as a hub for scientific research, Earth observation, and human spaceflight. It supports long-duration missions, allowing 3 astronauts to stay for 6 months and up to 6 astronauts during crew transitions, ensuring a continuous human presence in orbit. The station consists of 3 main modules: the Tianhe Core Module, which houses life support systems and living quarters, and 2 laboratory modules, Wentian and Mengtian, dedicated to scientific research. Together, these provide about 4,000 cubic feet of habitable space, enabling astronauts to conduct extensive experiments in microgravity, life sciences, and advanced materials research. The modular design also allows for future expansion as technology and mission objectives evolve. One of Tiangong's most important features is its advanced scientific research capabilities. The station is equipped with 23 enclosed experiment racks, each designed for different research fields, and external platforms for observations in space science, Earth monitoring, and astrophysics. Unlike previous Chinese space missions, which had limited research durations, Tiangong enables long-term studies on microgravity's effects on biological organisms, combustion processes, and materials manufacturing. China has already conducted several key experiments aboard Tiangong, many of which are aimed at supporting future space missions, including potential lunar and Mars explorations. One significant study focuses on growing plants in microgravity, which is essential for sustaining long-term space missions. Understanding how plants grow without Earth's gravity could lead to the development of space-based agriculture, a crucial component for lunar or Martian colonies. Another area of research involves fluid physics, a field that behaves very differently in the weightless environment of space. These experiments help scientists understand how liquids and gases interact in microgravity, leading to advancements in fuel efficiency, medicine, and industrial applications. Additionally, Tiangong's Materials Science Laboratory is studying metal alloys and composite materials in space, with the goal of developing stronger and lighter materials for future spacecraft and advanced technologies on Earth. Beyond scientific research, Tiangong serves as a powerful Earth observation platform. It is equipped with high-resolution imaging systems capable of monitoring climate patterns, natural disasters, and environmental changes. This data is valuable for meteorologists, geologists, and policymakers, helping with disaster response and environmental protection efforts. As Tiangong gains recognition as a major space research facility, the international community has taken notice. While many experts see it as a technological achievement, its completion has also raised concerns about geopolitical competition and space security. China's exclusion from the ISS due to US restrictions pushed Beijing to develop its own independent space program. With the ISS set to retire by 2030, some nations, including Russia and several developing space programs, view Tiangong as a possible alternative for future research. The European Space Agency had previously considered sending astronauts to Tiangong, though recent political tensions have made this uncertain. Despite the potential for collaboration, concerns remain over space debris and satellite safety. In 2021, China filed a complaint with the United Nations, stating that Tiangong had to perform evasive maneuvers to avoid collisions with satellites from SpaceX's Starlink constellation. This incident highlighted the growing problem of space traffic management and increasing congestion in low Earth orbit. Critics argue that as more spacecraft launch every year, stronger regulations are needed to prevent accidents and ensure the sustainability of Earth's orbital environment. As global competition in space intensifies, Elon Musk has shown particular interest in China's space station. Reports indicate that he visited Tiangong in person, though details of his trip remain scarce. However, sources suggest that his impressions of the station left him deeply concerned. What worried him was not the station's technical capabilities, which he reportedly found impressive, but its potential for rapid militarization. During his tour, Musk reportedly noticed several modular attachment points that were not included in any public documentation. These components could, in theory, support military-grade surveillance systems or weapons platforms with minor modifications. He was particularly struck by an advanced AI-driven autonomous system, supposedly designed for station maintenance and debris avoidance. However, with his expertise in artificial intelligence, Musk recognized that the system's capabilities far exceeded what would be necessary for basic station operations. According to a source close to Musk, he muttered, "It's happening," while reviewing his notes from the visit. The source suggested that he believed China's space station could be converted from a scientific outpost into a military installation within weeks, if not days. His concerns focused on the station's advanced optical systems, which appeared far more sophisticated than needed for scientific research. Combined with AI capabilities and strategic positioning in low Earth orbit, these systems could provide China with unprecedented surveillance capabilities over military installations and communication networks worldwide. Another troubling observation was the station's ability to quickly adjust its orbit without the usual fuel consumption associated with such maneuvers. Musk reportedly noticed what he believed to be an experimental propulsion system, possibly using ion thrust technology that is far more advanced than anything publicly known. If true, this would allow Tiangong to reposition itself quickly, making it harder to track or monitor. Despite these concerns, Musk has remained diplomatic in his public statements, emphasizing the importance of international cooperation in space exploration. However, sources indicate that he has privately been advocating for increased transparency in space operations and pushing for new international treaties to prevent the militarization of orbital platforms. What do you think about these developments? Should there be stricter regulations to prevent the use of space stations for military purposes, or is this just part of the ongoing competition in space?